using all along, man. Where you been? Okay, you guys have questions on homework? Does anybody want me to go over any problems from homework? If you do, hurry up because we are wasting recording time right now.
Can you do number 54 on page 667?
Oh, are you speaking loudly so you can get recorded?
Can you do number 54 on 667?
I'll try, no guarantees. Okay, so how's the date? Yes.
Bobby's showing how many lunch days with girl.
Are you going to tell us more about it? So we can go in the annals of history?
I'm not recording this lesson, so tell us. Lunch day.
What? You know, to tell or you didn't go? Or she stood you up? She stood you up? Oh my God, she did. She did.
Wait, who was she? No! Bobby.
Shannon, what number did you want, Shannon? Shannon, what number did you say?
Number 54.
54. Yes. Yeah. All right, so this is all about parabolas. Well, what page? Yeah, parabolas, right? Page 668. Can I use the F word while I'm being recorded? Oh my God. All right, so serious stuff going on now, okay? What the? All right, get this down, and then I'll talk more about it, okay? So this is what it's saying, okay? If you've got 2 points, and I'm just going to put them on an axis somewhere. One here, and another one here. I'll call this focus 1, and this one focus 2. Then if you pick a point in space, say somewhere out here, such that this distance plus this distance is equal to, say, pick another point out there. Okay, if the black distances and the blue distances are equal, okay, then what's going to happen is that you're going to get these points that I picked to sit on an ellipse. Okay, ugly diagrams, but sorry. Yeah, it's pretty ugly. In my past life, I would never do stuff like this. Just got studentitis. Okay. Right, does everybody understand this? So actually physically the way you want to think about this is that, say you've got a string that is longer than this distance, okay? If you've got a string that's longer than that distance, and if you tie the string at the two foci, kind of put a nail in there and tie it there, and then put a pen at the other end at some point in the string, okay? And keep it taut as you move it around, okay? Keep it tight so there's no slack in there. If you move it around, what you're actually going to trace out is an ellipse. Because the fact is that the distance that you talk about, like the blue distance and the black distance there, that is the length of the string. So as long as the string is tight, you're going to make an ellipse out of it. That's what this is saying basically. Okay? All right? Let's go take a look at equations, okay? Let's take a look at equations. So, just as in parabolas, we had two different kinds of equations, okay? One for parabolas that are horizontally oriented and one for ones that are vertically oriented. You got two things for ellipses as well, okay? Two things for ellipses as well. And the way you tell whether the ellipse is horizontally oriented or vertically oriented is by knowing which of the numbers in the denominator is bigger. So like, for example, So for this one, if A is bigger than B, A is always bigger than B, actually, by the way. I shouldn't be saying that. A is always bigger than B. Always bigger than B for an ellipse. And I'll explain that to you in a minute why. If the bigger number is under X, then it's horizontally oriented.
So just A is under X.
Yes. And if A is under Y, so bigger number under Y, then it is vertically oriented. Does everybody understand what I mean by orientation? Do you guys want me to sketch that out and show it to you in more detail, or you can picture that? Yes, exactly. Exactly. Does anybody want pictures on that? You guys got that? Susie? You good? You good? Or you want pictures? Sure, I can draw pictures. So this one here would be oriented like this, where it's longer this way than it is that way. This guy here would be oriented this way. It's longer this way than it is that way. Okay? All right, is everybody okay on that stuff now? All right. So know that A is always bigger than B, and I'll show you why that is the case in a minute, okay? So here are a lot of factoids about ellipses that you want to write down, and more importantly, commit to memory. And it's like I've told you at the beginning of this chapter that this chapter is not hard per se. It's just that too many factoids in there, and you screw up one factoid, then your ellipse becomes a hyperbola. And if you are on a hyperbola, you get ejected out of the universe. Get it? Get it? Get it? Get it? See, if you're in an elliptical orbit, you're going round and round and round and round and round and round. If you're in a hyperbolic orbit, you're gone. You're gone forever.
I think my jokes are better.
Okay. But remember, I've got control over your grade, including your joking grade. So, okay, get this down. And then, okay. So what I want to discuss is this thing here, and this is the reason why A is greater than B. That is the reason. Need I explain?
Yeah. I don't wait. No.
And it cannot be negative cause, sorry? Yeah. Okay, it can't be negative because it's a squared number. A squared number is not negative if you want to be in the real world. Okay, is everybody all right there? Okay, is everybody okay? All right. All right, talk about eccentricity. And the eccentricity is just the ratio of C over A. Okay, and C is what? What did you write down? C is what? And A is what? Anna, A is what? Yeah, Shannon?
Half the major axis.
Or said in another way,